Aristotle believed that all materials on Earth were not made of atoms but the four elements: fire, earth, water, and air. He believed that all substances were made of small amounts of these four elements of matter. The theory of Aristotle led to the theory of Democritus. He believed that everything is composed of atoms, which are physically but not geometrically indivisible, that between atoms there lies an empty space, that atoms are indestructible and have always been. It will always be in motion, and there are infinite number of atoms. Between 1772 and 1794, Antoine Lavoisier found that mass is conserved in a chemical reaction. The total mass of products of a chemical reaction is always the same as the total mass of the starting materials consumed in the reaction. His results led to one of the fundamental laws of chemical behavior, which is the law of conservation of matter, which states that matter is conserved in a chemical reaction, meaning that no matter will be lost. In 1803, Dalton came up with his atomic theory, that all matter is made of atoms and atoms are indivisible and indestructible. All atoms of a given element are identical in mass and property. Compounds are formed by a combination of two or more different kinds of atoms. A chemical reaction is a rearrangement of atoms. In 1897, the British physicist Joseph John Thomson discovered the electron in a series of experiments designed to study the nature of electric discharge in a high vacuum cathode ray tube, an area being investigated by numerous scientists at the time. Thomson interpreted the deflection of the rays by electrically charged plates and magnets as evidence of bodies much smaller than atoms. That he calculated as having a very large value for the charge to mass ratio. Later he estimated the value of the charge itself. Robert Millikan in 1909 did an experiment that determined the size of the charge of an electron. He also determined that there was the smallest unit charge, or that the charge is quantized. Millikan's experiment was that he put a charge on a tiny drop of oil and measured how strong an applied electric field had to be in order to stop the oil drop from falling. Since he was able to work out the mass of the oil drop, he could calculate the force of gravity on one drop. He could then determine the electric charge the drop must have by varying the charge on different drops. By 1911, the components of the atom had been discovered. The atom consisted of subatomic particles called protons and electrons. However, it was not clear how these protons and electrons were arranged in the atom. J.J. Thomson suggested the plum pudding model. In this model, the electrons and protons are uniformly mixed throughout the atom. In 1923, James Chadwick discovered the neutron. This changed everything because in those days most researchers believed there were electrons within the nucleus as well as outside of it, and some others believed in the possibility that particles with no charge could be in the nucleus. Once Chadwick discovered the neutron, everything changed. In 1924, Louis D. Roger postulated his theory that the wave nature of electrons suggested that all matter has wave properties. This concept is known as the de Broglie hypothesis, an example of wave-particle duality and forms of a central part of theory of quantum mechanics.